Welcome back to AkamaiTV. I'm Peter Cho, Principal Architect here at Akamai Technologies, and I'm joined here this afternoon by the legendary Will Law. Will.
Hi, it's actually two guys with dubious accents talking about tech, but we'll go with AkamaiTV.
Thank you. So in this session, we're really going to talk about kind of the state of the industry as it is today, and kind of just talk about some of the things that are happening that are making players easier, as standards are coming together, and really just kind of take a snapshot for where we are today. I'm sure if we have this conversation again in even 3 months' time, some of the things we will discuss right now may have changed quite radically. So Will, what are you seeing here at the show this time around? And what's your feeling about some of the things that we're seeing happening in the standard size, particularly maybe in like the codec space to start with?
Yeah, so let's start with AV1 because that's the flavor of the day. I think AV1 is very interesting from the technical side and from the political side and what it's doing to changing the standards landscape. And we're in the 4th day of IBC, I should remember. So my voice is commensurate with the number of meetings and talks we've had. It's been very interesting, so apologizing for that in advance.
Not a problem.
So AV1 came from the Alliance for Open Media, which was itself an industry response to the dysfunction that happened with HEVC royalties and patent pools. Yeah. So AVC, which is the H.264 family of codecs, were very successful. They're dominant on the internet today. Probably 98% of all media moving is that codec. Yeah. Because it had a fair and reasonable licensing scheme, there was one, MPEG-LA was the sole pool, people bought into it, and it allowed the codec to flourish. And HEVC was intended to be MPEG's successor to that. Yeah. And it came out 4 years ago, but it came out with a very fractured licensing and royalty landscape. There were 3 competing pools. I
was going to say, there were multiple pools.
Yeah, there were, not just one, so people didn't know where the pools were. A lot of companies declared IP haven't yet joined a pool, and the pools have been declared haven't yet publicized their licensing.
It must make it very hard for publishers and end users.
There was instability there, and out of that, a large group of companies decided we can make a business on codecs without actually licensing the codecs themselves. We have other ways to make money. We're OTT vendors, we're browser makers, we're hardware makers. We want a ubiquitous, high-performing codec. So they set about making one. So they formed an alliance, and they declared it to be royalty-free from the start. And this just got released in June of this year, which is AV1.
So is this showing up in browsers now? Is this going to be available?
So there's, I believe it goes Chrome M69.
Okay.
It comes out, and then it's in Firefox nightly right now. Oh, okay. So we can expect the 4 major browser code bases to support it, because the 4 companies that build those browsers are all inside AOM.
Right.
And it'll come out on browsers first.
Okay.
What's really going to influence its use, though, is hardware enablement via chips.
Of course, because we don't want our batteries to drain on our cell phones.
There's significant decode complexity above AVC for it today, and
do you know what the ratio is versus?
I don't want to misquote a number, but the complexity is significantly more than AVC for decode, and considerably more on the encode side, and that's what's holding back AV1 today. The encoders, BBC just put out a study yesterday showing comparing AV1 encode times to something called VVC, which is the MPEG successor to HEVC. And they were showing
That's the versatile video codec.
Yeah, it's called versatile video codec. Interesting name, because I wouldn't have said versatility was the top trend.
I'm sure I've heard versatile video codec in the industry before, but you know, let's see. Terminology tends to get recycled after a certain period. Yes.
So, but VVC was showing better quality in their tests than AV1.
Okay.
But we've got to be careful on which implementation of the AV1 reference they were using.
Which reference code?
And it significantly showed a 5-fold increase in code complexity over HEVC, whereas AV1 was showing, with their chosen implementation, a 100-fold increase.
Okay.
And so if VVC genuinely is that much easier to encode than AV1, it could bode well for VVC.
Yeah.
And interestingly, something happened here in Amsterdam yesterday, which was the inaugural meeting of the MPEG Coding Industry Forum, MCIF.
Yes, okay.
Entirely new forum.
Yeah.
And it's a group of licensees and licensors of HEVC. And they're trying to fix the somewhat broken deployment. Really in anticipation of VVC coming out and getting it right, I believe, for VVC.
Okay, so they're going to try and avoid the let's say, train wreck is not the right word, debacle. That's probably
it's
not the right
just,
word.
it's unfortunate.
It was an unfortunate situation.
A lot of good work went into it. HEVC is a good codec. It's getting usage. Bitmoving put out a study this week as well, showing usage is up on HEVC this over last year. And it's primarily Apple flew their flag and said we're supporting it across their ecosystem. So if you want to do 4K on an Apple TV, you're going to use HEVC, and that's where we're seeing a lot of the usage today. But it's absent on the web. And the web, I think we'll get to it later in our discussion, is driving more and more media playback today. So if codecs need to be a first-class citizen on the browser world.
But if the codec isn't in the silicon on these very cheaply produced devices that you can attach to the back of the TV.
Well, there's another political problem there too, because it's often like HEVC on Qualcomm chipsets is available on all their chipsets. But you're running Chrome browser on a Qualcomm phone, you still can't use HEVC
because it doesn't
because Google want a consistent codec experience, so they do it all with software.
Okay.
Microsoft Edge, under certain circumstances and browsers and hardware combinations, will go down and support codecs that the browser itself doesn't support, but the underlying operating system does.
So that's interesting. So you see on the mobile devices the same kind of thing we've seen in browsers, which is this abstraction layer occurring where the browser or the JavaScript environment is able to access the very high-powered hardware in a very nice, simple, extracted way.
Yeah, so I mean that's basically MSE and EME, and that's been a nice break that we've seen come about in the last 6 years now.
Yeah.
So when HTML5 video first came out, it was the video element, and you fed it either a monolithic MP4 or later on you fed it an HLS M3U8 and it could do adaptive bitrate. Yeah. But it did it all by a black box player.
Exactly.
You don't even, today you can't even ask it what bitrate it's playing. It doesn't tell you. It's that much of a black box. And people in professional video who want to build players that are optimized for low latency sport or high stability VOD playback, they want to be able to adjust buffer algorithms.
They want more levers.
They want to fetch content from different places. They want to parse the manifest. So media source extensions was an enhancement to the video element, which created a virtual source, if you will, that's attached to a video element. And this virtual source has buffers that a JavaScript application can populate. So you can write a player that parses a manifest, either HLS or Dash or Smooth, you will make up your own, fetches segments using XHR or Fetch API, does bitrate adaptation, appends this binary data into the source buffer, and then the browser and the operating system do the heavy work of decoding the content.
Got it.
And that allows a lot of flexibility in the player development, but still high performance. You can do 4K with essentially a JavaScript player.
So this explains why when I'm watching Netflix in my browser, I don't have to install anything.
Exactly, and it's a great experience. And
Isn't
Netflix is, Netflix, you can think of Netflix as an icebreaker, and YouTube too, for that matter. They were instrumental in both initiating MSE and in its development over the last 5 years and in making it robust. And there's a lot of work going on with projects like the WAVE program at CTA, which is trying to standardize the environment for HTML5 playback. There isn't a test, until 2 months ago, there wasn't a test you could run on an arbitrary television that you knew nothing about.
No.
How good is its HTML environment for playback? Now there's a suite of tests that Wave's developed that you can run, and it'll give you a score. And it'll tell you, is this TV commensurate with the 2017 snapshot? Which was what were all the APIs that the 4 major browser code bases supported in 2017. And at least you can now start categorizing your hardware support on devices that were previously the Wild West. You had no idea how your app was
So
going to work.
you see that strategy applying to mobile and other bespoke hardware devices out there?
Mobile is where all the development and work is done. There's a lot of native app usage.
And the SDK layers and stuff that people have to build out.
And but that energy and enthusiasm is there. And televisions were always excellent at taking over the air broadcasts and playing content. And then smart TVs came out, all with these very fractured development environments. And I need a polite turn of phrase for how difficult
Every
it
TV
was.
was a smart TV for a while.
Yeah, they were smart until they had 16 ways to write programs every different year amongst vendors. So the TV vendors don't want to carry the burden of their own operating system and application development environment. They would be quite happy to say, we provide a first-class browser-based environment. You can write apps for that, and you can write the same apps on your television as you put on your phone, your media player, and your smartwatch. And there's a vision of the future there. It's not there today in its entirety, But we're moving towards that, where it's the best thing we have to a converged application environment that still delivers performance, quality, security, reliability, and performance.
So talking about convergence, I mean that's in this very high energy environment of media, and especially with the internet and video. The traditional broadcast space maybe moved a little slower in the past, but the internet moves very quickly, and as these two worlds have merged, we were very fractured for a while in terms of containers and video formats and audios. There seems to be quite a lot of convergence, at least in the codec.
Convergence is happening. So it's happening with the presentation format. How do you describe content? It used to be HLS, smooth, move networks, HDS,
real,
and real networks. And we went from proprietary protocols to HTTP. Excuse me. And then from HTTP,
now let us scale, of course.
We've converged down to essentially two today: HLS and MPEG-Dash. And these are the two now. There's still a lot of smooth for legacy devices, but no one would be incorrect today to say, I'm going to build a solution that's forward-facing, that is only looking at HLS and Dash. And they used to differ. So HLS has used TS segments to hold its audio and video data. Dash allowed TS and ISO based, but practically only the ISO was ever brought to market by anybody. So you had a problem for people encoding and producing and storing content. They had to make two copies of everything. One in a TS box and the other in an ISO box. So thankfully, led by Microsoft and Apple and a MPEG effort among a number of companies, of whom Akamai was one actually, came together and formed CMAF, which is, its initial name was Common Media Format. It was just a box that everybody could use. And MPEG being MPEG put an A in there for application.
Four-letter acronyms, no three-letter acronyms.
Well, an application in MPEG speak is a collection of other standards that are assembled for a purpose. And essentially CMAF is the ISO-based media file format with some additional restrictions. So it is an application, but people think of applications as executables that run on your phone.
It's one of those overloaded terms.
CMAF, so there's two myths about that. One, it's somehow executable. Secondly, that it's an alternate to HLS or Dash. It is not. CMAF
it's a constriction of HLS or Dash.
It's a file container that's used with HLS. So Apple has supported what they call fragmented MP4. Fragmented MP4 is CMAF. I should say CMAF is fragmented MP4. It's a subset of it. For the last 2 years now.
So that means people's phones that they cycle through and devices, we're at the page where that kind of adoption curve is now, where there's a significant portion of devices.
I saw numbers like 85% of well, it depends which country you're in.
Of course,
So, but in the United States, I think today about 85% of all the Apple ecosystem devices are supporting HLS with CMAF. So it's, I think in the end of 2018 and 2019, we'll start seeing companies who are addressing especially the mobile device environment primarily, and not set-top boxes, they're going to begin harmonizing around CMAF. They'll produce an HLS and Dash manifest, they'll produce the CMAF containers, they'll cut their encoding and storage costs in half, and they'll double our CDN efficiency in terms of caching, which is good.
Because we only have to store one copy,
right? We store one copy of the same thing instead of two, and they fight with each other for limited space and cache.
So I think CMAF helps us get past having to keep multiple copies, but then there was always this wrinkle that there were two different versions of the encryption. So where's Common Encryption right now? So
Common Encryption is one of the standards bundled in with the ISO-based media file format. Common Encryption acknowledges the fact that there's three or four, depending how you want to be. It's Fairplay, Widevine, and PlayReady, the major ones in the US. And they differ in how they set up the initialization vector. So there's actually 4 modes allowed under Common Encryption that are completely uncommon with each other.
Of course.
Different binary implementations. So today, even if you use Common Encryption with CMAF, you have to do your CBCS for Fairplay, and then you do counter-based for Widevine and PlayReady until the last 12 months, in which both PlayReady and Widevine have implemented CBCS support in their implementations. Now, it's not backwards compatible to the older devices.
So again, we're in the same device wave curve of...
Legacy devices are always the issue in media, but every day you go forward, your legacy problem is smaller. You have to wake up and tell yourself that. It's slightly better today than it was yesterday.
Every day is a new day, and it's slightly better than
until a new codec arrives, and then everything crumbles again. But we are, I believe, slowly moving towards a common CBCS implementation of CE and C. that we can combine with a common CMAF container.
So we
and
truly
then
will
attach
have
2 manifests.
Yeah.
And as chairman of Dash Industry Forum, we could also converge to one presentation format if you all want. But honestly, maintaining the 2 text files against the media objects is not the hard part. It's the heavyweight video fragments, especially, that we care about most in terms of scale and delivery.
And so anything we can do, that has a net benefit on a CDN as well as on the customer storage, of course. So much as we enjoyed storing 8 copies of your files, just storing 1 would be.
But it's really driven by business economics, how much you store today, because there's always that Samsung TV from 2014 that needs smooth, and you're going to, as long as you have enough audience and paying subscribers, you've got to support them. So mostly these formats are kept around for the edge cases of support that haven't reached the point where you can cut them off or ship them a free dongle so that they can play it in a more modern way.
So I've been hearing about IMSC1. Can you unpack that for me? Because this is another coming together of
so we've
standards.
had, talk about convergence, we've had multiple caption formats. 608, 708 embedded captions.
You wouldn't believe how hard just the text. We get the video from one side or the other, but we can't get the text there as well.
And then on the website, there's the Web VTT is popular, but Web VTT is a relatively simplistic implementation of captioning. If you have a single person speaking, single color, XML, and it's down at the bottom of the page, it's perfect for that, and it's very simple. But when you get into the production of captions and you go under the covers a little bit, you realize there's tremendous complexity there. Multiple speakers, multiple colors, positioning, animation, scrolling up, and then that's for Western languages where we read top to bottom and left to right. But there's languages that read right to left and read vertically, and you need a format that's complex enough to accommodate all of these needs. And we don't want just one for those and then a different one for everywhere else. So there's been a TTML branch of captions, of which SEMTTT was one of the first. And EBUT, excuse me, there's day 4. EBUTTD is a derivative of that. It's the European delivery version of the captions.
I had some challenges. I was trying to set that up, and in the end, we were working through WebVT versus EBUTTD, and trying to make sure my encoder was configured correctly.
So what's happened is W3C now has made IMSC1, which you could think of as a master version of the TTML branch of captions, and EBUTTD fits into it. And really, this is the convergence caption I believe we should all get behind. The Wave project has made a media profile about that. Apple has supported it, so Apple supports IMSC1 natively and across its ecosystem. And I really hope the rest of the industry, I just came from an IMSC1 meeting, everything's pointing towards it being adopted, because we don't gain any material benefit from modifying different captions. And today in the production workflow, you might distribute your master file with one caption, and it gets translated and converted to other caption formats for delivery.
We've got
the beauty of IMSC1 is it's rich enough to be the master caption format, with the ideal, hopefully, that it can move from the master format all the way through delivery without being changed, which is not a workflow we have today, but it would be a desirable workflow in the future. Excellent.
So I think that covers a lot of the convergence. I was walking around here, and one of the things I see again and again is everyone's chasing latency down. So I know we've been talking about various things in this space before. We've been doing demonstrations of like WebRTC. We've been doing demonstrations of how we can, basically take the delay out of different products in this workflow chain. So modifying the way the encoders work, doing things with the way origins publish data, and how. What are we seeing here, and where do you think this is going right now?
So if you're in the broadcast world, a lot of people, or even consumers generally, have a notion that OTT is far behind broadcast. And it did indeed used to be. There used to be a default of 10-second segments when HLS first came out. And the Apple player, which is a black box player, likes to have 3 segments in memory. So you already had 30 seconds of latency right there. And this has been whittled down by reducing the segment duration. So today across the Akamai network, if you use 1-second segments, you'll probably get 5 to 6 seconds of end-to-end latency with three segments in the player buffer. 2 seconds will get you 8 to 12, somewhere in that line.
So we're just trying to game the player, basically.
We're really just shortening the segments. But there's a new development now that's pretty popular at the show, and if you want, is there some buzz in live streaming, this would be it right now, which is called chunk transferred chunk encoded CMAF.
Okay.
And again, CMAF is not the
There's a lot
presentation
of
format.
chunks and
it's
segments
yeah,
in there.
so there's
let's-
two
let's
double
unpack this a
uses
little
of
bit.
chunk.
Yeah.
So three things have to happen to get low latency out of this. It's a system, not you don't just use CMAF segments to get low latency. You won't get anything latent.
It's going to work the same as HLS or
So
Dash.
the encoder firstly has to chunk encode the content. What this means is if I got a 6-second segment, normally I would make a move atom which is like an index, and then the MDAT is holding 6 seconds of data.
Yeah.
And
These
I
are-
would
these are
make
the
all of that, and
subcontainers inside
I
Dash,
have
right?
to wait till I've made the last byte to go write it into my index. So
Yeah.
I can only release the first byte when I've finished the last byte.
So I have to fill up my container.
Fill up a bucket of water before I hand it
And
on.
then I hand it off to the
okay?
origin, yeah.
And you can picture distribution as a bunch of people handing buckets
Yeah.
one to another.
Yeah.
And the latency accumulates as
Because if they have to pass a whole bucket over, I had to
an
wait.
integer amount of the segment
Yes.
duration, which is our bucket volume in our
Yes.
going to get complex quickly analogy.
Yeah.
So what CMAF does is say, hey, I'm not going to make an index for the whole segment. I make a move and I can reference just one frame of data, 33 milliseconds. And when I'm done that, I take that little tuple and I start sending that to the CDN.
Post that immediately to the origin.
And you do it on a HTTP chunk transfer, which is a way to send data when you don't know how big it's going to be.
That's the protocol we've had for 15 years
It's
or so.
old. Yeah, so
It's
old
'cause
is new.
when we had these large progressive downloads, we didn't want this, 3 megabit per second video, which was our
Yeah.
super high quality, to just saturate my poor
Yeah.
poor internet connection and wipe everyone else out. I
Yeah.
wanted it to download at 3 megabits, which is the rate I needed.
So
there.
it's not a new protocol at all for
Yeah.
HTTP, but it's very useful. We combine the chunk transfer. It has the
Yeah.
same name, which is very unfortunate. We combine chunk transfer into the CDN.
Yeah.
Then the CDN has to chain together these chunk transfers
Yeah.
through an origin. And this is complex because the
So
origin
chunked, chained, chunk. Yes.
chunk. Yeah, there's enough C's in there.
I was going to say we can go to a C3 at something.
Yeah.
Excellent.
This is something Akamai's done with our media services live
Okay.
and our distribution layer, which
Yeah.
is our adaptive media delivery.
Yeah.
We can continue the chunk transfer all the way down to the client. So the client will request the full segment, a
Yeah.
6-second segment, and it'll start getting the first frames as they're being made almost by the encoder, and
Okay.
it can start decoding them. So the client will be decoding the front of the segment
Yeah.
while the encoder is still producing the tail.
So we've
And-
got rid of the bucket, basically.
yeah, so think of
The
it as a
water is
bucket
just
with
pouring.
a hole in it, pouring into another bucket with a hole in it.
Yeah.
And I pour water in the top bucket, it just flows all the way down to the bottom one.
Yeah.
I don't have it tipping over
We don't have
anymore.
the buckets falling over each time.
And what
Oh,
this
that
does
makes
is
sense.
decouple the end-to-end latency from the segment duration.
Yeah.
So I can have a segment of 6 seconds, but I can get latency of 1.5 seconds.
That is very impressive. So I think we have a demonstration of that here at the booth. If people would like to come by and see that, we can certainly, when you're here, we'll be able to show you that. And I think even this broadcast is being sent out in that format.
It
So
is. We're broadcasting live, and we've been watching it all day, and we have a stream coming from Boston right now being
Yeah.
encoded. 720p, 2 megs,
Yeah.
6-second segments. We're getting 1.5 seconds of end-to-end latency here in Amsterdam. And this is done with chunks that are 1 frame in size.
Yeah.
So it's working across the production network, and this is quality and latency we could deliver essentially to anyone in Western Europe.
Yeah. So again, that's an excellent demonstration you're able to see here at the booth. And Will, I thank you very much for your time. I'm excited to talk to you again here at NAB. Hopefully, if we do this again, and maybe a lot of the things that we discussed here will have changed quite
There
dramatically.
will be. We can come back and correct what we said here. So we'll have part 2, the truth, in next year.
Well, we'll have the next 6 months of where we are. Will, thank you very much for your time. This has been a fascinating conversation. That's it for this segment. AkamaiTV will continue in about half an hour's time. Thank you very much.